All right, squaring a binomial. I would not have put this in this section, but sometimes Alex does some weird things, and after you build a section, then it throws stuff in. So this is u plus 7 times u plus 7, which gives me u squared plus 7u plus 7u plus 49. Excuse me. U squared plus 14u plus 49. Okay. Hopefully, you see the pattern. 7 plus 7 is 14, and 7 times 7 is 49. And hopefully from now on, you can just do these in your head. So if I had x plus 3 squared, that's going to be x squared plus 6x plus 9. If I had x minus 11 squared, it's going to be x squared minus 22x plus 121. Got it? All right. X-intercepts and y-intercepts. This question's really tough. The x-intercepts are negative 2 and 2. And the y-intercept in this case is 4. Piece of cake. Next question. How do we find the x and y-intercepts of a line? Well, what is the value of y on the x-axis? We'll pick a point on there. This point right here is negative 4 comma 0. What about that point? Negative 2 comma 0. This point is 0, 0. The x-axis is every single point where y equals 0. So if I want to find the x-intercept, all I have to do is plug in 0 for x. So in this equation, if I plug in 0 for x, that goes away, and I'm left with negative 3y equals 18, divided by negative 3, y equals negative 6. If I want to know what the y-intercept is, or the x-intercept, oh, I did that backwards, sorry. I plug in y equals 0, and I get 16x equals 18, divided by 6, x is 3. Okay. My goodness. All right. All quadratic equations, all x squared graphs, either look like this or like that. The shape of that graph is called a parabola, and parabolas are extremely common in the natural world. Lots and lots of equations can be modeled using parabolas. Okay. How does a parabola, what does the shape look like? So let's graph y equals x squared. We build a table, x and x squared. So 0 squared is 0. 1 squared is 1. Negative 1 squared is also 1. 2 squared is 4. 3 squared is 9. Negative 2 squared is also 4. So this parabola starts at 0, 0, and the graph is over 1, up 1, over 2, up 4, over 3, up 9, and so on. The left side is going to be the same. Over 1, up 1, over 2, up 4, over 3, up 9, and we get this shape. Now, we can move that parabola around using the formula y equals x minus h squared plus k. When we did circles, both the h and the k were negative. But that's not true of parabolas. The h is negative, but the k is not. Anytime your h is inside the parentheses, it's going to be negative. Anytime it's outside the set of parentheses, it's going to be positive. So, oh, you can't see the equation. So, what is my h value in this equation? -4. The number on the inside is positive, which means that my h value is -4. What is my k value? 3. So y equals x minus h squared plus k. The vertex of this parabola is either the minimum or the maximum. -4, 3, that's the vertex. And then what's the pattern? Over 1, up 1, over 2, up 4, left 1, up 1, left 2, up 4, and then I draw my parabola. If you plot your points and you draw your parabola and you get something that looks really weird, then you messed up. Okay? All right, what if my parabola was y equals x minus 1 squared plus 2? Where is the vertex? Right 1, up 2, and then same pattern. Over 1, up 1, over 2, up 4, over 2, up 4. Now, there is a way to flip a parabola upside down. And that would be putting a negative out front. But this question is not going to do that. There's also a way to make a parabola taller or shorter. So if you were to put like a 3 here, then your parabola would be 3 times taller. If you were to put a 1/3 there, then your parabola would be 1/3 as tall. All right. Okay, this is a really tough question. Does this open up or down? Down. What is the vertex? -4, 1. Axis of symmetry. What is the equation of the line that cuts this parabola exactly in half? Well, it would be the line x equals -4. A vertical line is given by x equals, a horizontal line is given by y equals. So this is x equals -4. Okay? And what are the x and y intercepts? So x equals -6 and x equals -2. Those are the x-intercepts. And the y-intercept is -3. Okay. And last question. All right. So y equals x squared looks like this. So x equals y squared is going to look like this. Okay? A negative x squared would be a sad parabola, and a negative y squared would be a left opening parabola. So, excuse me, I need to get this in x equals form. So x is equal to 1/4 y squared. So that starts at 0, 0. And what happens when y equals 1? What does x equal? So we put a 1 in there, and we get y equals 1 is x equals 1/4. I don't really want to graph that one. Okay? So what about y equals 2? 2 squared is 4, and 4 times 1/4 is 1. So 1, 2. And then the bottom is going to be the same, 1, -2. Would plugging in 3 give me a nice number? 3 squared is 9. 9 divided by 4, not a nice number. What would be the next number that is a nice result? 4. So let's plug in y equals 4. 4 squared is 16, and 16 divided by 4 is 4. So 4 comma 4. So 4, 4, and 4, negative 4. So this is the parabola. Okay. What if I had y equals 3x squared? Okay. So my center is 0, 0. What about x equals 1? When x equals 1, what does y equal? 1 squared is 1 times 3 is 3. So 1, 3, which means negative 1, 3 also works. What about 2? 2 squared is 4, and 4 times 3 is 12. So 2, 12, and negative 2, 12. How does that compare to the normal parabola? Well, the normal parabola was over 1, up 1, and over 2, up 4. Over 1, up 1, and over 2, up 4. And you'll notice the new parabola is exactly 3 times taller than the old parabola. So you just need to plug in either x's or y's until you get numbers that are nice. And in fact, you don't really need nice numbers. If you ended up with 1/3, 2, you can use this button and plug in 1/3, 2, and it will put that point on the graph for you. So either way. Question? Well, don't do that. All right, get to work.